So while it's also important to think about physical and chemical properties, those give you the foundation to think about physical and chemical changes. So a couple of examples. A physical property could be something like the density of an object or the hardness of an object. And a physical change would be something where its state has changed. So ice melting into water, or water evaporating into water vapor. These are all examples of physical changes. Vice versa, water vapor condensing into water and water vapor going into solid ice. These are also examples of physical changes. Now, chemical changes, you can ask yourself basically the question, does this substance change on the molecular level? And sometimes that's easier said than done. But a couple of examples. Wood burning. Well, wood on the molecular level is probably going to be made up of cellulose, a bunch of other stuff as well. But what that's going to break down into is carbon dioxide and H2O. Yes, there are going to be other substances, but basically the molecular makeup of this wood prior to being burned is going to be different from what it is after the fact. Another example that people like to think of is a bicycle chain. A bike chain, let's say that it has a bunch of iron in it. Well, that Fe, that iron, reacts with O2 in the atmosphere. And what that's ultimately going to produce is something like Fe 2O3, iron oxide. This Fe is a single atom. And of course, it's lots of those single atoms, but that will react with O2 to produce this Fe2O3. So think about it as, does it change on the molecular level? Are bonds made or broken in this process? If bonds are broken or made, that would be an example of a chemical change. Whereas if the state of that substance just goes from a solid to a liquid or a liquid to a gas or vice versa, well, then that's going to be a physical change. I hope this is a helpful way of looking at physical and chemical changes.